Hey guys, hope all are fine. So today we will see a basic LED circuit and how to change the current flowing through an LED. Okay, so first let me draw the circuit. So this is the source. Usually the source will be a 9-volt battery. So in this case I am taking a 9-volt battery, okay, and a resistor in series and an LED. Okay, so I have taken a 3 mm LED and I have taken a 1 kilo ohm resistor. So first, this is a 9-volt battery. So first we will discuss about this circuit, and then I will tell you how to vary the current flowing through this LED. Okay, so generally first what we are going to do in this circuit, we are going to find the current. Okay, that is the current flowing through this resistor. Okay, the current flowing through this 1 ohm resistor, 1 kilo ohm resistor. Why 1 kilo ohm resistor? Because this resistor and LED are in series. The current flowing through this 1 kilo ohm resistor is the current which is flowing through the LED. Okay, so basically if you take any LED, the average current required for any LED will be between 12 milliamps to 20 milliamps. So if you give current anywhere between 12 to 20, it will glow perfectly with good brightness. Okay, so in any circuit, make sure that you provide 12 milliamps to 20 milliamps of current for an LED. Okay, so first what you are going to do, we will check the current for this circuit, and then we will see how to vary the current to this LED within this limit. Okay, so here we will see two calculation. One is theoretical calculation and the other one is practical calculation, which means I have a circuit, a real-time circuit. We will check what is the current flowing in that circuit, okay, in real time. Okay, so first we will complete our theoretical one. So as I told you, we are going to calculate the current I. Okay, so I is equal to, as per Ohm's law, we know I is equal to V by R. Okay, so now what I told you, we are going to, as I already told you, current flowing through this 1 kilo ohm resistor is the current flowing through this LED. Okay, so we are going to find the current flowing through this resistor. Okay, so I is equal to V by R is Ohm's law. Now we are going to find the current flowing through the resistor. So I is equal to VR divided by R. So what is VR? VR is nothing but the voltage drop across resistor divided by the resistance value. This is the current flowing through the resistor, that is IR. Okay, IR and the current flowing through LED are same. So we are going to find IR. Okay, so IR is equal to VR divided by R, where VR is the voltage drop across resistor and R is the resistance. See, generally before calculating VR, we should know one thing, which is Kirchhoff's voltage law. See, in any closed circuit, according to Kirchhoff's voltage law, the potential rise will be equal to potential drop, which means the source voltage will be equal to the addition of all the voltage drops of all the components available in the circuit. So in our circuit, we have 9 volt. Our only voltage source is 9 volt. So this 9 volt is the only source. Source means the device which provides current. Okay, so the 9 volt battery is the only source. So 9 volt is equal to the addition of all the drops. Okay, addition of all the drops. So we have two components, one is resistor and the other one is your LED. So we have drop across resistor and we have drop across LED, which is VR plus voltage across LED. Okay, so here we do not know what is the voltage drop across resistor, because this value varies from value to value. For different resistor value, the voltage drop across resistor will vary. So we don't know for this circuit. So what we are going to do, we are going to keep it in one side. VR is equal to 9 volt minus VLED. Okay, but VLED we can easily know, because the average voltage drop across any LED will be 2 volt. Okay, so 9 minus 2. Exactly not 2, but somewhere around 1.9, 2.1 it is. Okay, you can verify this in the internet also. So you take any LED 3 mm or 5 mm for any color, the average voltage drop across any LED in any circuit will be 2 volt. Okay, So 9 minus 2 is 7 volt. So we have got the voltage drop across resistor, which is nothing but, see, this voltage drop across resistor is nothing but 9 minus your voltage drop across LED. Okay, so now it is very easy for us to calculate the current, that is IR is equal to VR divided by R, which is equal to VR is 7, which we have already found out. Resistance value is 1K, that is 1000. Okay, so this is 0.007, so which means 7 milliamps. So theoretically 7 milliamps current will be flowing in the circuit, which is having 9 volt battery and 1 kilo ohm resistor connected in series with a 3 mm LED. Okay, now we have to see practically what is the value we are getting for this circuit. Now I will show you the voltage of the battery which I have chosen before connecting it to the circuit. Okay, so as you can see, we got 7.3 volt. Okay, so 7.3 is the voltage which my battery is having before connecting to the circuit. Okay, usually this voltage will vary the moment you connect the battery to your circuit. See, this is because the moment you connect some loads or components to your source, there will be a voltage drop in the battery also, because of the components available inside the battery and because of the drops. So we have to check what is the voltage in the battery after connecting the circuit to your battery. Okay, so before connecting our battery to the circuit, it was 7.3, and after connecting the battery to the circuit, you can see it is only 3.9. Okay, so this is because of the drop. So now we will come to our circuit. So 3.9 is our main battery voltage. Okay, so instead of 9 we are going to write 3.9. Okay, this is after circuit connection. Okay, this is before circuit connection. Okay, that is open circuit. Okay, so 3.9 is equal to VR plus VLED. So what is the voltage across our LED? I will show you in this circuit. The voltage drop across LED is 1.92 volt. Okay, so from this VR is equal to 3.9 minus 1.92. Okay, so what is the value? Is 1.98. So from this IR is equal to VR by R. So VR is 1.98 divided by the resistance value is 1 kilo ohm, which we have chosen 1000. Okay, so the value is 0.00198. Okay, so if we convert this into milliamps, we will get 1.9 milliamps. So for this particular circuit, theoretically we have seen 7 milliamps of current is flowing, but practically for the same circuit, okay, the same 9 volt battery I have taken, but the battery voltage is only 3.9 after I have connected it to the circuit, and 1 kilo ohm resistor and then 3 mm LED, the current flowing is 1.9. so which we will check it in our real time circuit. So where will you connect your ammeter in this circuit to check the current? So you have to connect it here. Connect the positive of the multimeter here and negative of the multimeter here, and set the multimeter in amps, milliamps. So this is your current. Okay, you have to connect it here. So you can see the current flowing is 1.74. Okay, so practically it is 1.74, and the answer which we are getting is 1.9. More or less it is equal. So there will be small difference because of, like we might have missed some decimal point, and because of those we are getting different value, but this is the real time value. Okay, and this is the theoretical calculation. You can check the difference between theoretical calculation and the real time value. So it is 7 milliamps in theoretical value and it is 1.74 milliamps in real time value. Okay, so always understand these points. Always when you connect a battery to your circuit, there will be voltage drop. See, from 9 volt it is only 3.9 volt. Of course my battery is having only 7.3. If I am taking a new battery, it might be much greater than 3.9 also. So always make sure that you calculate the voltage of your battery after connecting it to the circuit and before connecting it to the circuit. Okay, so now it is very simple. Now what we have to do, our ultimate aim is to make sure that whatever current we want to flow through the LED, that must be flowing, right? So we will assume here that I want 15 milliamps of current to be flowing through the LED. So this is our requirement. Okay, so in this case we know what is the current. This I, see, this is the current which should be flowing through the LED. So 15. So we know this I. So I is 15 milliamps. Okay, so you can directly substitute in this formula. I is equal to VR by R. So 15 milliamps is equal to VR divided by R. So R we don't know, because by changing R only we are going to vary the current flowing through this LED. Always remember guys, by changing the resistance value we are going to change the current flowing through this LED. So we don't know what is the value of R. So we are going to find the value of R, and if we connect that resistance value to this circuit instead of 1K, we will make sure that 15 amps will be flowing through this LED. Okay, so R is equal to VR divided by 15 into 10 to the power minus 3. Okay, so what is VR? VR we have already found out, which is practical value. I am taking practical value. Okay, 1.98 divided by 15 into 10 to the power minus 3. So what is the value we are getting? 132. So you need to connect 132 ohms resistor in place of 1 kilo ohm, so that 15 milliamps of current will flow through this LED and your LED will be glowing brightly. Okay, so that final value. So in any circuit, if you want your current or your range of current to flow through your LED, you have to change the resistance value. So this is the method to calculate the resistance value. So you have to replace this 1 kilo ohm resistor with 132 ohm resistor. So if you don't find any 132 ohm resistor in your market, then you can go for any nearest value. Slightly your 15 milliamps will change, might be 15.5, whatever it is. Okay, but somehow the current should be more or less equal. Okay, but this 132 ohm resistor is only for circuit with 9 volt battery, which is having only 3.9 volt after connecting it to the circuit. In case if you are taking a different battery and that battery is having different voltage after connecting to the circuit, you have to take that voltage. So be clear with that point. Okay.